comes in, there's this angular bracket G, and you know what your task is, because you are the machine. Pretty well, what's the first thing you would do? Just common sense. What would you do? Well, you'd probably check that the input stream that's supposedly this is what it says, what it claims to be, that it really is a representation of a graph. So you would check that the format of the string is in the form of a graph. Okay. In other words, there should be, you're going to check that there are two lists. One is a list of the nodes. Okay, so you'll check the format that there is a list of decimal integers, and you'll check that there's a second list, and that list consists of pairs of decimal integers. Okay, that'll be pretty well the first thing you do. Well, let's just check and see if I got that right. So you're going to check that this is a proper encoding, a proper no errors representation of the graph. So how do you do that? Well, so you'll scan through the list. No, you'll scan through the tape. Okay, the input string. You'll scan through the input string, or the tape if you like. Now this is sort of shorthand. Remember a Turing machine tape, according to Sipser's version of it, it has a boundary on the left side, but extends infinitely on the right-hand side. Okay, so when you talk about tape, scanning the tape, that doesn't mean you move the head infinitely far along the right. It just means you move it until you get to the first blank. Okay, that's what scanning. I mean, common sense, right? So you scan the tape, and you're checking to see that there are two lists. Right? So how would you do that? Well, that's getting a bit too low level in detail. But you'll check that there are two lists, and they're in the proper form. In other words, the first list is a list of decimal digits, or decimal integers, let's say, and that the second list is in the form of pairs of decimal numbers, or decimal integers. Okay, that's what's said here. All right. Okay, so assume it does that. Now, if there are errors, now remember this machine M is to be a decider. Okay, so it either accepts or it rejects the string, each string, every string, any string, accepts or rejects. So if there's an error in the representation, then it will reject immediately. Okay, so assume. Okay, so we're down to here now. Assume that the format, that the two lists are appropriate, that they're proper. I mean, there are no errors. The representation is correct. In other words, this representation here is a correct, proper, if you like, representation of a graph. Okay? And it has the two lists, and the lists are of the appropriate format, and so on. Okay, so we're down to here, and let's assume everything's okay. If not, immediately reject the string. The input string is rejected. Okay, so now keep imagining you're the machine. What's the next thing you do? Well, more checks. Let's see. Going down slightly, finer level of detail, you can check that, like the first list. So the first list, we'll call that the node list, right? Because it's the list of nodes. And the second list, of course, is the list of edges. Okay, so the nodes list and the edges list. Right? So we're talking now about the first one, the first list, the node list. It should have no repetitions. That's sort of obvious, right? That list, that node list, there'll only be one instance of a node number. Right? You're not going to you're not going to label two different nodes with the same integer, right? That's sort of pointless. So if an error has been made in labeling the nodes, so that you do get a repetition of an integer, a node number, in other words, that's an error. Okay, so if that happens, reject. Okay, so you're checking that there's no repetitions in the node list. Okay, and another thing you check for is that in the edge list, have a look at every node number in the edge list. So have a look at every node number in each pair in the edge list, and see that that node number also appears in the edge. In the node list, right? So to be consistent, you don't want to have because you'll need this consistency for the processing that comes later. So you're checking now to ensure, I guess, that the node list is complete or is compatible with the edge list. Like if there are node numbers in the edge list that do not exist in the node list, well, you've got a problem, right? There's something missing. Okay, so check for that, and if you find an error, reject the string. Okay. Now going down now. So how would you? Now we're at implementation level of detail, right? So how would you do the first? How would you check that there are no repetitions of node numbers in the node list? Well, we did something like that in a previous exercise. Go back to exercise 3.12. Let me give you the page number in the text. 3.12. Page 149 in the textbook. Okay? In section 3.1. So example 3.12, 3.12, page 149. Now in this example, we're talking about a machine that we labeled, a tuning machine we labeled M4, and its job was to, it was given a list, instead of having commas, it had, I think, hash signs to separate strings, and the exercise was to show what the Turing machine was to accept the string if each substring, separated by hash signs, if they were all different from each other. Okay, they're all distinct. If, you call each string substring an element, and so this machine here was checking for element distinctness, and each substring was different from all the others. Okay. Now you could do something like that for checking that there's no repeats of the node numbers, and you can create a similar algorithm for checking that all the node numbers mentioned in the edge list, that node number is also a member of your node list, right? You don't want anything missing. Okay. All right. So now assume if any errors, always reject. Okay. This machine M is a decider. Okay. All right. Now, say we've got this far and everything's checking out so far. Now, so if the input string passes these checks, then it means that this input string is an encoding, a representation of a graph, right? You know that. So so in a sense, all these checkings are just sort of preliminary. You know that the information coming in is of the correct form. It has the correct format, and now the real work can start. Okay. So this is sort of preliminary verification process, checking that the format of the input string is correct. Now assume that that's done, the verification, the checking, has been completed. So what happens next, and you probably see this first line of the next session, what happens next is the real work can start, and so Turing machine M can move on to stage 1 after having checked the input tape. Now it knows that the input string is representing, encoding a graph. It knows that it's a graph, so now it can extract the information and start working on it. Start checking, in other words, whether this input string represents a graph, an undirected graph. But the critical question is that graph connected? Right? That's what it's all about. This Turing machine M is a decider. It's to decide on whether the stream represents a connected undirected graph. Okay? All right, we'll go on to the next session.